For those of you who are absent, when we're talking about handout 2.4, lesson 2.4, the chemistry of air and altitude. So you should have already read the article, maybe made some notes, highlighted things, and annotated that article, as well as tried to answer those 7 questions on 2.4b on your own thinking. So because you're at home, you won't have that second box filled out that says, after discussing with your partner, because you don't have a partner. I mean, I guess you could talk to your mom or your dad, maybe your dog, and see what they had to say, but that might not be as helpful as another student who's learning the same material as you. So we're just going to go with final answer after our whole class discussion. That's the discussion that me and you are having right now. So let's start with this very first question. What would the partial pressure of nitrogen be in a room in which the total pressure was 0.987? So because we know that the percent of nitrogen in dry air is 78.1%, then all you have to do is take that out of a percentage by dividing by 100, so 0.781 gives you that relative abundance, and you'll multiply that times your total here, and 0.781 times 0.987 should give you a partial pressure of nitrogen of 0.771 atmospheres. So that should be your answer here. For number 2, it says if a sample of air in a closed container was heated, would the total pressure of the air in the container increase, decrease, or remain unchanged? And explain. So we know from our past experience that if we increase the temperature, we're going to increase those collisions, and so that pressure would go up. So the total pressure in the container should increase because as you have particles moving with a higher kinetic energy, they're going to make more collisions and more forceful collisions with the side of their container. Number 3, if a sample of air in a closed container was heated, would the percent of oxygen in the air increase, decrease, or remain unchanged? And explain. Well, because it's in a sealed container, the percentage of oxygen cannot increase or decrease unless there is a hole in your container or you are adding more air into that container. So this would have to remain unchanged in that container because it's sealed. Number 4 then asks, if the sample of air in a closed container was heated, would the partial pressure of oxygen increase, decrease, or remain unchanged? So again, adding heat to those oxygen molecules is going to make them hit that container more, and that's going to increase the pressure and the partial pressure of that container that has the oxygen in there. So that gets us to number 5. Right, where it says welding is an industrial process that's used to join pieces of metal. A certain mixture of gas in welding is composed of carbon dioxide and argon. The partial pressure of carbon dioxide is 0.080 atmospheres, and the partial pressure of argon is 0.24 atmospheres. What's the total pressure of the mixture? So when we have 2 partial pressures and we want to know the total pressure, right? If we know that the partial pressure of one gas in the mixture and the total pressure, also the total pressure of a mixture is the sum of all the partial pressures. So all you have to do is add those 2 numbers together to get 0.32 atmospheres for number 5. Okay. 6 asks what fraction of molecules on that mixture are argon. So now, because we know the partial pressure of argon is 0.24 atmospheres, and now we know the total pressure in the mixture is 0.32 atmospheres, that's your fraction. 0.24 divided by 0.32 is 0.75. Some people in the class also wrote 3/4 because they really wanted it to look like a fraction, but it's okay to have decimals. 0.75 atmospheres, or 0.75 would be our fraction of those molecules. And then 6 says, when you travel in an airplane above an altitude of 10,000 meters, the cabin of the plane has to be pressurized. So for a passenger and the crew's safety, based on the reading, what do you think pressurized means and why is it necessary to do this? So remember, as we fly higher in the atmosphere, um, our pressure decreases. That includes the partial pressure of oxygen that we need to breathe. Think about hikers that are climbing Mount Everest and how they need to bring oxygen tanks, or they have to do it in a way that is safe for them because the oxygen level is so low. The same thing is true in the airplane, except they need to increase the partial pressure of that oxygen gas so that people can breathe on the airplane. That's what they mean by passenger and crew safety. The ability to breathe is more safe. 7 says if you were to draw a particulate representation of air that has 10 particles, how many of the particles would you draw would be nitrogen? How many would be oxygen, argon, or carbon dioxide? And explain. So we're going to go all the way back to those percentages here, right? So nitrogen is 78%. You can't draw 7.8 molecules, so we'll just round that up to 8 molecules of nitrogen you would need to draw out of 10. And oxygen is about 21%, so again, we'll round that down to 20. 20% of 10 is 2 molecules, so you would have 8 nitrogen and 2 oxygen, and 8 plus 2, that's your total of 10. Now that means you would draw no argon or carbon dioxide because their percentages are so low that in that diagram they would not appear in that representation. If I asked you, you had to draw 100 of those, maybe you could draw 1 argon, right? That's how little that percentage is. It would round maybe up to 1% right there. So you would just need to draw in number 7, right? 8 particles would be nitrogen and 2 particles would be oxygen. The other 2 are negligible or would not need to be represented in a sampling that small. Okay? So that's the end of 2.4. There is an assessment that you need to take. The code to that assessment is MPRESS, IM lowercase, press all big. I'll write that down on this sheet of paper. Little I, little m, capital PRESS, emphasizing the word MPRESS. Okay. So if you'll take that assessment and also do the PL, that will do. See you next time.